Cool. So I think some folks might have their mic unmuted. So if you just want to check your mics before we get started, and I will go over a few things. Cool. So you kind of just give me a nod or a sign that some of you found the video that I made about the lab 5, which is this week's lab. Awesome. Okay. Great. And so we'll give that a try, see how that works for you. But I think, you know, the lab part is really more just a walkthrough intro, and then actually now I can kind of take advantage of showing a few slides that relate to that lab, but just getting that extra bit of time out of the way and not taking up this lecture time, I think will be helpful. So if you have a specific thought on that after you try this out, I'd love to hear, as far as, yes, this is really the way to do it, let's keep doing that, or no, it's still not quite working, maybe I'd like some more live interaction about the lab, then that's something that I can potentially just set up individually with you through Zoom, or set up a separate like lab meeting time where we meet as a group if there's enough of you interested. So just those kind of comments are helpful, again, just to kind of hit the right notes with each of you as far as what you're getting from this class. Another update I have is just the online, so I'm just going to share my screen here. Oh, well, I can't actually show that part because that would show everybody's grades, so I'm not going to do that right now. But what I did want to mention about that is that in the grade book area where you can see your grades, what I did was I adjusted the totals side, which is the farthest end, where, you know, like all of your exam scores are going to be kind of, you'll have your individual exam scores, then you'll have like sort of a cumulative exam score, same for homework, same for current event, for the field report, and lab exercises. So each of those I actually associated the percentage of the total grade that's going to be there, so that should help the grade book essentially just pre-calculate for you and give you a more accurate running account of what your grade is in the class. So that's the point there. But just some reminders there. The exams are worth 25% total of your grade. All of them, all 4 of them together. All 13 labs are worth 35% of your total grade. So that's the biggest chunk. So make sure you're just consistently working on those labs. And then the online quizzes and homework, which I'll pull in from the Mastering Geography site at the end of the semester, is worth 15%, so don't forget to do those. Then you have the current event critical thinking that I will talk about today. That's the next item on my list. And then the field outing report that I also want to mention. So the current event, the critical thinking global processes, is 10% of your total grade, so full grade. And then the field experience report is 15%, a grade and a half, to get you to 100% for the class. So the current global processes, what that is, and so here I have the modules. So I set this class up with these modules. These are all assignments that you could find in the assignments area as well of YO courses. But if you go to modules, it'll just help you like chunk it out into week by week. So we're in week 5. And again, you just want to make sure that you get everything done that's on here. And obviously the due dates appear right there with the assignment. So February 23rd, Lab 5, Mid-Latitude Weather. And then this critical thinking and global processes. And what this is this is an assignment that for each of my classes, it's important to me these days to have a critical thinking component for you as students to just practice being critical of where you get your information, what kind of information is it, what is it telling you, and, you know, do you agree with it or not? Because there's so much of this sort of, you know, the popular term is fake news out there these days, of just stuff that's just made up. And anybody, you know, I can create a web page right now and go along with, you know, something like the Flat Earth Society and say that, you know, the Earth is actually triangular, it's shaped like a pyramid, the Egyptians made it, you know, and off we go. So, and somebody will believe it, right? Because they're not necessarily thinking critically and being like, maybe I should check the sources on this and the science behind it, so on and so forth. That's the point of this exercise. And so it's all laid out right here. I want you to just look through these links. You're welcome to use other ones. The topic is climate and global processes, okay? So you're welcome to use other sources. I just want to make sure then if you do that, of course, just cite the source in the sense of like, give me the link or give me the title of the journal or the author, and that sort of stuff. But here's some to get you started, 5 different links, and you're just gonna flip through those, check them out, and then see what grabs your attention, and then read a little bit more about 4. You have to pick 4 from all of these resources here. So this one, for example, has 20 within its one link, you know, 20 different concepts. You're going to pick 4, and for each of those 4, each one of those, you're going to name the concept that you picked and that you're talking about. You're going to provide the source of where you got this information from, and then you're going to describe in your own words what this concept or issue is. So let's say it's about acidification of ocean acidification. And so then you're going to provide the source where you found this information about ocean acidification, and then you're going to describe ocean acidification is the large-scale absorption of carbon dioxide into the actual water system of the ocean. And then that, just like a soda is acidic, like a Coca-Cola or, you know, Mountain Dew, Pepsi, all that kind of stuff is acidic. Part of that acidity is coming from the carbonation, the CO2, that makes it bubbly, makes it gaseous. So just like that can has that acidic, like you pour that out over, you know, on top of something, like say your paint job on your nice car or whatever the case may be, it will start to eat away a little bit at it. Well, that's what's kind of happening to the oceans right now, because they're absorbing, right? It's this huge surface area. 3/4 of the whole surface of the earth is covered in water. That is absorbing excess carbon dioxide and causing then a whole systemic change as far as for the animals that are adapted to live in it at a certain acidity level, as well as kind of other processes. So that's my own words, right? I'm trying to explain that. You're going to make sure you do it in your own words, not copy and paste or just write down exactly what you saw there. And then, because that helps you think it through. And then you're going to say why this was of interest to you, that topic, or and why you think it's important for the earth, or I'm going to do a quick little edit here, for the earth and or society as a whole. So why is it not letting me? Oh, it's still working. Maybe I'll just edit it later. So that is your critical thinking, and you're going to do 4 of those. And then, do you believe this? Do you skeptical about it? Do you think it's a myth? Because you might pick some things. There's stuff that I included in there that are total falsehoods, but they were important to include in there because there may be things that people commonly believe, right? You know, something along the lines of like the flat earth, or other things about climate process, for example, like, oh, it's been really cold the last 2 days here in Laramie, Wyoming. So much for global warming. I think we can move on now, right? But, you know, there's more to it than just like 2 days, for example, of weather. And so those sort of things are what you're just going to explore on your own. Pick your favorite 4 and describe them. And then you're going to upload it as a Word doc into this assignment heading right here. And boom, I will grade that for you. So that is due by Friday at 11. So have a look at that. Get going on it. Remember, you have to do the lab too, so don't bundle everything up until just the last minute on Friday night. Again, just a friendly reminder, I have these things set. They're all available a week ahead of time. So you have at least 7 days to do any one of these assignments, if not more. But the minimum I give is 7 days. So just because it's due on Friday at 11 doesn't mean that you have to start it on Friday at some time. You're welcome to start it today, Wednesday, or 2 days ago on Monday, and just check it off your list and it's done. All right. The computer doesn't care if you turn it in 5 days early. That's totally fine. So Just a little helping thought there. And then the field outing idea, that is big kind of semester project. And so I want you to look here on week 6. Next week, you'll see this little field outing idea link. Now it says it's worth 0 points. This is a completion or incomplete part, this idea piece, but it gets factored into the final grade of the field report that you do at the end of the semester. So that's how you do get credit for this. Just right now, you don't get credit. It's just an incomplete or a complete, and then I factor that into your final grade, which is, as I said, 15% of the total. And so what you're doing is you're just going to give me 2 to 3 sentences, a description of where and what you plan on doing for your field project. The field project is in here under assignments. Click on that, I recommend, and get the full description of what I'm asking you to do for the field project. But basically the idea is you have to have a unique experience that occurs during the course of this semester. And it's related, and then you're going to relate the experience to physical geography. So, for example, if you went to Hawaii when you were 6 years old, that doesn't count for this assignment. If you go to Hawaii over spring break in 2 weeks, that could count for this assignment. All right, but you don't have to go to Hawaii to do this assignment. I'm not obliging anybody to do anything beyond, what your transportation and access is. But I encourage you to try and, go to some kind of natural place and spend some time out there, and you're going to describe at least 2 to 3 specific physical geography concepts that you encounter while you're out there. So this field outing idea is just what you think you would encounter as far as, okay, I'll give you an example. I'm going to Vedavu up the road here from Laramie, and that's where there's a lot of rock formation, so I'm going to expect to observe geologic processes, rock types, erosion, weathering, and also while I'm out there, I'm going to make some observations about weather and climate. And I'm going to describe what the weather is that day, what type of clouds there are, what the temperature is, what the difference in temperature between Laramie at 7,200 feet was and Vedavu at 8,500 feet, and why there might be a difference. And those are some of the concepts. Maybe I'll look and see if if you end up out there and you find a moose, then you might be talking about a little bit of, the types of animals that are adapted to the ecology of the environment around Vedavu. So there you go. That's what you're just sharing your thoughts. The reason I want this in by the end of next week is because spring break is typically a time when folks take advantage of getting this project done. So you're either already got a trip planned and you're going to Cancun, Mexico, or you're going to Moab, Utah, or you're going to Devil's Tower, or you're not going anywhere, but at least you're not in school, so you have a free morning or an afternoon. Just throw yourself out somewhere. You're going to go ski at Snowy Range ski area for a half day or whatever the case may be. That works. So start thinking about that and put your thoughts down in this little assignment heading. Great. So lecture time then, I guess. Tried to move through stuff. Does somebody have a question for me about these assignments?
Do you have a rubric for the field outing?
I have a very detailed description.
Okay.
Let's start with that. And then if you feel like you need some more specifics or guidance, I'd be happy to check in with you. Yep. So let me just look at, since we're here, assignments. And then field report. So it's titled field report. And this gives you a very detailed description that you'll be able to pull up. And it says what you must include. So it's, sort of.
So I don't see that in mine.
Okay, let me check.
It just says no submission.
Maybe I have it locked still. So,
okay.
No? Let's see.
So if it says that you need to, you see the blue kind of breadcrumb thing at the top, you have to click on field report up there. So.
Okay. Cool, thanks. Is that Hunter? Yeah, thanks for, so you're able to access it, Hunter?
Yeah, if you click on it under assignments, it'll go to the submission page as if you've submitted it. So if you click on the blue link with the assignment name at the top, that'll fix it.
Perfect. Thank you. Does that make sense? Is that Sam? No.
Hold on.
Okay.
I went to assignments and then I clicked field report and then it says this assignment is part of an unpublished module and is not available yet.
Ah, I see that's interesting. Okay.
I get the same thing.
Do you? Okay. So let me see this on I see those two published. I'll take a look at it. Maybe what I'll do is right now, what I'll do while we're talking, and I don't want to take up too much of everybody's time, but I will throw that into next week's module for the time being, because that's a published module with the field outing idea. And let's see if that fixes things. So I'll have one of you check this as I start doing the lecture, and then just give me some feedback. Let me go ahead and just find this, put it in there, field report. And okay, so that is thrown in there. Hopefully this remedies that. So when some of you that have computer access right now get a chance, and this might take a minute or two to work its way through the matrix and kind of fix itself.
It's in there.
Okay, and you're able to open it?
Mm-hmm.
Sweet. All right, cool. So that'll be there, and I'll try to remember to pull it out and put it in, its corresponding one. But otherwise, I think everything, the deadline there didn't change, so that's the most important part. Okay, cool. Awesome. Any other questions? So that was good troubleshooting right there. Anybody else see something that they want to check in on about, or?
Real quick, sorry. I haven't had time to watch the lab intro video, so forgive me if this is explained in there. But Lab 5 seems to be worth more than double any other lab we've had so far. Is there a reason for that?
Lab 5. So Lab 5, it says 35.5 points. Global climate's coming up next is 31 points. Oh, wait a minute. And let's see. I'm just trying to pull up my share so you can see what I'm seeing here while we talk. Okay. The rocks and minerals is 52. So the point allocation is kind of all over the board. But again, each lab ultimately at the end of the semester is worth proportionately. So 1/13 of the total. So, and it depends on, like, some of them just have a lot of like little kind of detailed questions, and it just kind of gave a value to each one of those questions. And other ones are, just sort of more big picture concepts, and it's fewer questions, and it ends up being fewer points on that particular lab, but it all shakes down at the end. That's a good question.
Okay, gotcha. Thanks.
Okay. Cool. Good questions.
Kind of more of a statement. The quiz 5 that we just took in homework.
Yeah.
It was all about soils.
Oh man, was it?
So I don't. That's not what I read. So, but I still kind of worked through it.
Yeah, bummer. That's my bad on that one. There was, I don't know why that soils one keeps floating around. I don't know what it is. And I had this problem a previous semester too. There's something magical about that one. So I apologize for that. And that should have been mid-latitude weather related is what it is. So I will get into mastering geography. What we'll do is those of you that got a score that you're satisfied with, we'll just apply that to later on in the semester. Those that didn't, you will just get the chance to redo that one later on in the semester. Does that make sense? So you get a redo on that one, and then I'll get that mid-latitude weather and have it available for you guys. Okay, but obviously the deadline will be changed for that one. Thanks, Brendan. Because otherwise I wouldn't have even known that, because that one is kind of on autopilot. So
yeah, there was like a few questions about mid-latitude letter, and then it all of a sudden started jumping into soil. But
really, that's weird.
Good thing the textbook online has a search option. So
yeah, yeah, but it just you do some quick flash, kind of scanning to try and just cover the questions. But that's not the point of this, to throw you into super kind of scan mode there and try and learn something off the cuff. So I will check that.
I had a
And
quick
with
question.
the homework and the quiz, or just the homework, or just the quiz?
Just the quiz for me, at least.
Okay. Okay, so just the quiz. Cool. And then the homework was probably more mid-latitude than related. And okay, so yeah, that was weird. Cool. Yes, somebody else had a question.
Yeah. Sorry, it's Montana.
Yeah.
My computer kind of was funky with Zoom. What did I miss the couple minutes I was off? If not, you can email me about it. But
Okay, cool. Just right now, you're saying?
yeah, like the first couple, like probably 5-10 minutes. That.
Yeah. So the main thing really was just for you to, if you just want to make note there, is go and check out the field outing idea and the field report assignments for week 6. So next week in the module section, and you're specifically going to respond to the field outing idea, and it's very specific about what I want from you there. But you're going to want to refer to the field report to know the big picture of what it is that is talking about for the idea. So that was probably the main thing that you missed there. The other one was just that the video is posted for the Lab 5, and that's online on YouTube, and that the global process assignment is due this week, and that's in week 5 of the module, and that is fully described there. Cool.
Okay. Thank you.
All right. Any others while we're on a roll? Okay, yeah, I'm just checking the chat. Some folks saying they saw some things. Same thing with the quiz, so I will fix that quiz. I'm glad at least the homework was.
I can't remember. Are the weights listed in the syllabus?
Yes, and they're on the first page of the syllabus.
Okay, I couldn't remember. I just wanted to make sure. I didn't need to ask.
And that should always be your go-to for everybody as far as if you have a question or a concern, check there first, because hopefully it's going to be there first, and then they can go from there. Cool. And I will switch screen then to the lectures for today. Okay. So as you know, I kind of like to ask questions of, existential questions. That's what physical geography is all about, in my opinion. And so a question for today is thinking about, why does it rain, right? We know why the sky is blue and during the day. We know why it's orange and red, and the sunset, sunrises. What else? We know the reasons for the seasons. So now, we want to think about what makes it rain. How does rain occur? And can you see this big enough if I leave it in this mode, or is that okay? Yeah, because I kind of like it like this, because then I can easily flip back and forth when I'm talking about something, if I want to go back to the previous slide or the forward slide, by knowing being able to reference that myself. So I think I can even make this a little bit bigger on my screen. I don't know if that changes the screen on yours as well. But okay, so actually that's too big. There we go. Mid-latitude weather. So moisture availability in air masses. You learned a lot about air masses in last week's lab. And that's something also, when you submit your labs, it might give you an initial grade, but you'll likely know, if you haven't noticed already, your grade typically goes up sometime thereafter that, because I go through and personally kind of review each and every answer, because the auto grader sometimes doesn't account for like a range of value that you could be finding when we're using like those funky little charts, and it's like you sort of had to pick a number in between and find a value that you kind of basically had to sort of guesstimate. Those sort of things, like kind of inaccuracies, I account for that personally for you, so that you don't get dinged on how you interpret this little graph on an assignment, and how the computer wants to just do one specific value. So I just wanted to, that just came into my head. I've been meaning to check in with you about that, each of you. That so those of you that came to office hours this week, talking about last week's lab, that was one of the things I emphasized. So know that. So a lifting mechanism. we learned about a lifting mechanism and air masses and moisture when we did that lab where we studied from the process from Seattle up and over a summit and then down and around to Spokane. That whole process was the changing moisture availability in that air mass as it was forced by being lifted up and over the mountains, the Cascades in that case specifically. And so we're going to look at some other types of mechanisms. That one is called the orographic uplift, and that's basically mountain lifting of an air mass. You can't go through the mountain, so it has to go over, and that lifting, as you remember from the dry adiabatic lapse rate and the warm, right, there's these rates of change that roughly every 1,000 meters or 3,000 feet you change about 10 degrees Celsius, right? And if you go up by 3,000 meters, 1,000 meters, 3,000 feet, does the temperature also increase or does it decrease as you go up in elevation? Yes, goes down. Thank you. Remember, it's going to decrease as you go, so it changes, and that's that sort of that delta symbol. Okay, and then we'll talk about mid-latitude cyclones, and these are not cyclones in the sense of tornadoes and hurricanes. These are cyclones in these spiraling, cyclical moving air masses that move all the way across the continent. So quick review is general atmospheric circulation. We have the most amount of insolation occurring along the equatorial region between the tropics, and that produces a heating air mass, a lot of heating here, and there's a lot of moisture in that area. And so the air mass, as it heats up, it rises. So the first thing is because it changes its density. The cooler an air mass is, the more compact and the more dense it is. As you heat it up, it expands. And so as it expands, it's the same mass, but now it's more volume, right? So imagine blowing a balloon up or stretching a balloon out. It's taking up more space, and so it's going to move, it's going to float up. It's going to get sort of pushed up. But as we just talked about, as that air mass goes up in elevation because it's hotter and it's more less dense, it's also going to then begin to cool, conversely, because it's going further and further away from the Earth. It's cooling down, and so it'll begin to compress, and then it'll compress to the point just like that air mass did when it went up and over the mountains from Seattle to Spokane, to where it reaches its carrying capacity and it can't hold that moisture, whatever moisture it has in it, and it reaches that lifting condensation level or dew point, or generically just it rains, right? And so these are happening. There's regular systems that happen in the tropics, and air moves. It goes up away from the surface of the Earth, and then it moves towards the poles. And that's what these orange cylinders are representing. These are these subtropical cells called the Hadley cells. And they produce these subtropical highs. And then what happens is after they've lost all their moisture over the equatorial zone, and they're moving poleward, they then dry out, and they begin to cool as they go towards the poles, right? Because we know there's a deficit of insulation as you go towards the poles, away from the equator. And so then they cool, which means that they're going to get more sort of compressed and dense. So then they descend right at around the 40 degrees, between 30 and 40 degrees latitudes, north and south. And that actually, as they descend, then it causes them to heat up, right? Because for every 1,000 meters of change that you go down in elevation, just like generally, except for some weird upslope patterns that we've had this season, you would assume that if you go down 2,000 feet to Fort Collins, it should generally be warmer than it is in Laramie, right? Because you're going down 2,000 feet, so the temperature should increase. And so this air does that, and that's where you have your desert zones around the world. And we'll talk about that in global climates coming up here pretty soon. So that was a quick flash review of general atmospheric circulation. And then moving on to talking about weather and climate now. All right, so remember, there are two different things. This was kind of going back to that joke I was talking about, global climate change and how the weather is on a given day, right? Those don't necessarily directly link to each other. Weather is the short-term day-to-day conditions, okay? And it's just like taking a picture of something. It's how it is at that moment, but that's not how you always are, right? In that, it's just that there's a picture, you know, 5 years later, you're gonna look different than that. And climate is the long-term trend. One way that I describe this in social context is that weather is like how you feel right now. Are you happy, sad, stressed, worried, confused? Okay, that's weather, just your given emotions at a moment. Climate is your personality overall, okay? And that's where you may be sad or tired right now because you didn't get enough sleep, you stayed up all night writing a term paper, and now you gotta sit here online and do physical geography class, and so you're tired. That's your weather right now. But your climate is your personality overall. You're a positive, energetic person on any given day. That's how you would be. Somebody that's known you for 20 years would say, oh, Johnny is this way. That's your climate, okay? The weather is, but today, Johnny is bummed about X thing, okay? So make sure you're clear on those two distinctions there. Long-term average of weather conditions, including the extremes within climate. Whereas weather, it's just whatever it is at that moment. And then global circulation patterns of those high pressure and low pressure systems that I talked about in this. And this is a good slide here to make sure you're familiar with, to understand, because it's three-dimensional. So I find it really helpful. And you have these high pressure zones and your low pressure zones. And the global ocean currents reflect those atmospheric circulation patterns. Why? Because the wind blows over the surface of the water, and unlike land, well, even though here in Laramie, dust and sand and things get moved, no matter, you know, not just because they're water, but anything gets moved here. But water is a liquid, and it actually is influenced by the friction, the surface friction of the wind, the consistent circulation patterns. It's just like if you were sort of to stir the water in your bathtub by just circulating your hand right along the surface of the water, not dipping it all the way in. But even then, eventually you'd start to get that circulation, a whirlpool effect, right, on the water in your bath. So these ocean circulation patterns are connected to atmospheric circulation. And so we get these sort of processes here. This is another great graph to look over. So you have the Hadley cells kind of jumping off the side of the Earth there, and showing how they rise and they move towards the tropics, and then they descend, and then you have these other westerlies here. So you have your highs and then your lows. So elements that contribute to weather is temperature, air pressure, relative humidity, a lot of these things that we were looking at in the previous lab. And then wind speed and direction, of course, is very important. And then seasonal factors, such as right now, we have less sunlight per day than in the summertime, right? Shorter days. We're getting longer and longer. We're not far away from, we're a month out exactly from equinox, right? So, and that's where the day and the night is 12 and 12. And then they'll continually get longer and longer for us in our case. So air masses on the Earth's surface. Each area of the Earth's surface, though, also imparts certain characteristics to it, right? Over the enormous Pacific Ocean, there's certain types of weather and behavior that are influenced by that largest undisturbed mass of ocean on Earth in that area compared to over Florida, right? That particular little peninsula of landmass that's surrounded by the Gulf Coast there and the Atlantic Ocean, that causes a different type of weather pattern than what's over the Pacific. And here, right in the middle of the United States, the North American continent, in Wyoming and Montana and up into Canada, we're the farthest from the oceans, right here in the middle, we have very different types of weather characteristics because of the continental influence as opposed to what they call the maritime or the ocean influence. So those are things to consider. That's why it's not all the same everywhere around the Earth. So air mass is a distinct body of air with a homogeneous or a like singular mix of temperature, humidity, and stability. So it can all sort of be described within a specific sort of characteristics. So then we call that an air mass, that's uniform in this sense. And that means it's distinct from some other thing, which is then going to be another air mass, like a high pressure and a low pressure, or a cold front and a warm front. Well, those two fronts we're going to be learning about today. And then the interactions of these air masses is what produces weather. A warm front and a cold front, different air masses, when they meet, right, it's like two cars, right? When they run into each other, there's a reaction, there's something that happens, and that produces weather. The classification of air masses, according to, I'm just gonna adjust my window here. Moisture and temperature are the defining things. And I'm going to repeat that all throughout the rest of the semester. If in doubt, look for the temperature of the air mass and the moisture content. Over and over again, I'll remind us that, but we'll start with just today. So moisture, for example, M is maritime, not moist, but maritime meaning ocean, and that's wet. And then C is for continental, and that is the dry as far as the moisture. And then temperature are these following ones: A for Arctic, P for polar, T for tropical, and then equatorial, which means literally right around the equatorial region, plus or minus, say, 10 degrees, whereas the tropical would be with, you know, up to 20 degrees, 23.5 degrees. And so then you combine the moisture and temperature to actually get the classifications, like MT, maritime tropical, or CP, continental polar. So you do want to be familiar with those, because we'll be referring to those in other contexts as well. And so here's a great map. Well, I don't say it's great, but here's a helpful map to refer to get an idea of where these things occur and the different names that are associated with them. Continental polar, you'd expect it to be, in this case of North America, right over sort of the North Pole and then descending down through northern Canada. Likewise, maritime polar, then it's going to be the coastal, the oceanic sides of North America. So along Alaska coast and also along the Newfoundland, Labrador coasts of Canada towards Greenland on the other side, on the eastern coast. And then maritime tropical, you would see the Pacific side there around Baja California and Mexico, and then also the Atlantic side with the Gulf Coast of the southeastern United States, Florida, and into the Gulf of Mexico. Okay. There's some just bigger views of it, a little bit more detail there, as you can see. And then these are different seasonal patterns. So this is the winter pattern, where essentially the tropical ones are sort of pushed down towards the equator, and the dominant ones are the maritime polar. That's what's influencing our weather right now, and as well as the continental polar. When we get these really cold spells, that's typically associated with some of that continental polar air masses coming down and descending. And then the summer one, where those ones are diminished. The continental polar is much more diminished, but the maritime, the tropical ones are really charged up in the summertime, because they're getting all that extra heat and warmth, and so they drive a lot of the precipitation patterns that we get in the summer, obviously influencing things like thunderstorm activity in our case, and some of those other more specific summer-related events. So this just kind of talks through each of those. I'm going to leave you to kind of look over those, because there's not much that I would explain beyond what's written on the slides here, as far as interest of time. And then, let me make this a little smaller. There we go. But, you know, one case is, this is a good case to just use as an example, is the influence of maritime tropical on the Gulf Atlantic air masses. This is why this is the most humid region in the continental United States, at least, is this region of the southeast. And that's because we have a really relatively warm body of water, which is the Atlantic Ocean. In this particular region of the Atlantic is the warmest zone of all of the, considering the Atlantic extending up into Iceland and Britain and Europe, Western Europe, and then down towards Africa, and then across through the Caribbean. This is sort of where the warmest point is on its cycle, on its circulation pattern. And so remember, the warmer that an air mass is, the greater its carrying capacity, because it expands. It's expanded. The colder, as soon as you cool something down, the air is going to condense, right, and get more dense. So expanded air mass, it has more volume to just chuck water into, absorb water. And if it's moving over a big ocean like the Atlantic and the Gulf of Mexico, then it can charge itself with that. And then as it goes over land, right, it's typically a drier situation, and often land cools a lot easier. The temperature fluctuates more here in Wyoming than it does at the equivalent latitude, let's say in Oregon or Washington State, that's moderated by the coastal effect. We have much greater temperature swings every day, typically, because of being right in the middle of the continent. Land warms and cools much quicker than a body of water does. And so that results in this influence of the distribution of annual precipitation in Georgia, Mississippi, Alabama, the Carolinas. And some other things to think of, though, that localized effects are like lake effect snow that happens in the Great Lakes. If anybody's been there, I haven't experienced this there, but I've seen it in other areas, and I'll show you in the slide in just a second. But that's where you have, remember, this is winter event, so the air mass is already cold, and it's continental polar, right, that's coming in from that northern Canadian region. It descends, and it's cold, so it's basically dry. It's very limited in what moisture content it has. And as it moves over the Great Lakes, like Lake Superior, Lake Michigan, Lake Huron, even though they may be partially frozen and they're like not anything that you would want to jump into in the middle of February, they are relatively warmer. That the air, the water and the air is warmer than where that air mass is coming from in northern Canada, in the middle of the Great Plains there of northern Canada. And so when it hits that water, it actually causes that air mass to warm up. And it heats up, it rises, and it absorbs. The other thing that water is doing, in addition to providing warmth, is moisture. It absorbs moisture from that lake, and then as it continues to cross over that lake heading east, it eventually gets to the leeward side, back onto land, which is much colder than the lake was, and it cools down quickly. So then it's going to cool, it's going to condense, and it's going to descend and drop moisture, because it's just losing its carrying capacity. It just gained carrying capacity over the lake and absorbed water. As soon as it gets over to the next section of land, it's going to cool down really fast, condense, and descend and drop. And that's where you see, I think I have a picture of it here. That's the bigger picture of the sort of the graph. But you see this, literally this sort of satellite composed image from Google Earth of that process. And here's an actual photograph of the blast zone. So you see, if you look left to right, specifically to the left of the mitten, right, of Michigan, that little hand that's right in the middle there, to the left of it's really dry, like where Chicago is and things like that. And then that air mass moved over, what is that? Which lake is that? Superior? Let's see. Lake Michigan, sorry. You can tell I've never been there. So there's Lake Michigan. And then it picked up that oil, and then when it landed back onto land, hit mainland, right where that mitten is there, the glove, you can see it just got blasted by snow right through there. And then this happens again as it went over the next lake, and then that side got hit, and that's sort of the Detroit area there. by snow, and then you can see it gets almost dried out before it gets to the next lake even there, the farthest lake to the right in this image. So you see this sort of dry lake, snow, and then it dries out, and then lake, and then the farthest to the right where the image disappears off of the slide, again you see snow happening on that far right side. So that's lake effect right there in multiple stages of what's happening. We have a similar process. Oh, this is something I think maybe I need to go to full screen for. With the Great Salt Lake. It's a much smaller scale, but relatively. Where are all the best skiing resorts in Utah? Just to the east of the Great Salt Lake and the Wasatch Range, the first range to the east of the lake, because you get a little bit of this dry air mass, cold air mass that flows over the lake, and it actually gets funneled just because of the way the basin and range is oriented here, and it channels an air mass through that lake, and then as it passes the lake and hits the first range of mountains, right, it's going to get that orographic uplift. It's going to cause it to cool and drop some snow, and you get all of that snow in Alta, Snowbird, or I can't remember all the names of them, but you get, and here you can see in the radar, so the red is precipitation. And so the lake is the black there, and then the precipitation occurring on the southeast side, because the storms typically come from the northwest, right, for us here in the west. So those are examples of the lake effect, so a localized situation related to land masses and water bodies. And so 4 atmospheric lifting mechanisms is convergent lifting, convectional lifting, orographic, and frontal. And these lifting mechanisms, the main thing that we're concerned about is they create precipitation from them. And so here's the figure straight from your text. And so you want to look over these, and I'll go through each one of these right now. So the first one is convergent, where you have a low pressure, where you have air masses coming together, and they're the same temperature, and they converge and lift. This is what's happening all the way around the equator, and it's called the intertropical convergence zone, ITCZ. Be familiar with that, because we're going to be coming back to that many times as well. That's the biggest convergence lifting event on Earth. That's happening continuously, and that's right along the equator where the air converges, lifts, and that's where you get so much rainfall right along the equator, resulting in the tropical rainforests. So that's this right here. Can you see that red square around the Hadley cells? Yep, good. So that's what's happening right there in that piece of the Hadley cell circulation pattern. The other is convectional lifting, and that's where warmer surfaces, it's heated and it rises. So this is what you have often over in continental zones, where like mid-continental, so Kansas, Nebraska, eastern Wyoming, right, some of the Dakotas, these big plains regions, is you get this heating of the land during the day, and it's really flat. It's not really broken up. You know, cornfields and things like that don't make a big difference on a large scale as far as disrupting a very even heating pattern. And so it causes that heat to heat up during the day, that air, and then it lifts. And then what does it result in? Afternoon thunderstorms, right, in the summertime. Very typical of these areas due to local heating. And on a larger scale, you might have maritime and continental influences too, where moisture and air masses coming off of the coast, so off the, say, the Pacific coast, onto the continent, California, Oregon, and you might get some convectional lifting that way as well. And this is something that you're familiar with now, the whole moist adiabatic rate and the dry, and so I won't go into too much detail there. This is a neat thing to think about, though, like that difference between the maritime and the continental effect. Remember, water doesn't want to change temperature very easily. It takes a lot of calories to get water to change its temperature. It's like it is the giant battery of Earth, as far as energy goes. And so if you look at this picture compared to the little map with the picture, right, you can see Florida literally outlined by clouds, right? And that's because the moisture being supplied, warm moisture by the ocean, the Gulf on the left, the Atlantic on the right, and then as that air just kind of moves over the land, that land is heating up much more quickly during the day, and so that moisture lifts, condenses, and creates clouds. You know, Florida, every day you can set your watch by thunderstorm activity, right? It has lightning storms every single day of the year as well, too. And that's because of these combination of processes of land and ocean. So therefore, you know, scheduling football games to any home team in Florida for 2 to 4 o'clock in the afternoon, you're just asking for trouble. And because you're going to get thunderstorm activity unless it's in a dome, which also would be a pain in Florida just because of the cooling costs. But those are sort of the dynamics that result in why Florida has these weather patterns, its identity that it has. Orographic, you guys did a whole lab on this one, so hopefully you're clear on this one. But the big thing to just take away for us as Wyomingites, or if you're anywhere in the western United States, is the rain shadow effect that this results in. That the western side is more moist and gets that precipitation because that's where the predominant weather patterns come from. And then as they're lifted up and over the mountains, they're wrung out basically of moisture as they cool, lose their moisture, and then the leeward side, or the rain shadow side, the rainy side on the west, the rain shadow on the east, is always that drier, more desert-like side of it. So right there alone, depending on what type of climate and precipitation you like, you know, take that to determine which side of a mountain range you want to live on in the west, for example. Do you want to be on the west slope or the eastern slope? Because that influences significantly your weather. And then there's just a few more details of what we've talked about. Produces specific wind patterns, but look at that map there of Oregon. Look at the picture of it too, the satellite image. Really green on the west side, really brown and dry on the right side. And that's literally just due to the orographic uplift effect predominantly. So frontal lifting is what we're going to spend the rest of our time on. I just want to check my time. Oof, running out of time. And that is, and I do explain this. I pick up right here as far as in the lab video. So you will benefit from that as well. Frontal lifting, cold air masses meeting warm air masses. Could be, say, for example, in this case, continental polar cold air mass, maritime tropical warm air mass. The cold air mass here is going to win the fight. It's because it's more dense, right? The colder the air, the greater the density, the warmer, the less dense. And so it's going to act like a bulldozer or a snowplow and just push the warm air up. And the key thing, though, that it does with that wedge is it causes the warm, in a cold front, it's going to cause the warm air to lift abruptly, quickly, in a short distance. That's the abrupt in this case. And what that does is that creates very dynamic weather events. So this is where you have your cumulonimbus, thunder, lightning clouds, heavy rainfall, intense rainfall, and maybe just short periods of rainfall. But it all happens and maybe some hail is going to be involved in there, right? It's just a lot going to happen in a short amount of distance in a short amount of time. That's the takeaway. One of the key things I want you to think of as far as a cold front process. And that's represented with these little blue sort of teeth that are the weather symbols for a cold front that you've seen probably over and over again when you watch the weather on the nightly news, but maybe didn't know what they were referring to. And then a warm front, the complete opposite. It's a cold, passive air mass, and the warm is just slowly, lethargically kind of just spreading itself over the top of it, smearing itself over. And it slowly gets lifted up and up and up and up until eventually you maybe get some drizzly rain precipitation out of it, but it's going to take a day and a half to happen instead of an hour or two. and the rain is going to just go on then and it's going to be cloudy leading up to it for like a day, and then the next day it finally drizzles rain, and then it passes over. Whereas that cold front is like, bam, here we go. Here's the storm event, and then, you know, kind of moves through. So, and then there's different cloud types associated with it. I won't expect you to memorize all the clouds, but you should be familiar with it. Cumulonimbus, thunderclouds, cold front. And some of these more wispy cirrus clouds, those are associated with the warm front. That would be the most I'd ask you to take away in that specific case of the clouds. And then here's all kinds of fun little images for you guys to play with to really help drive this home, because this is important. This is, you know, every day many of us check the weather, and this is the basic process that's occurring in one form or another for us. It always screws it up whenever I make it play, then I have to kind of reset my PowerPoint. So the mid-latitude cyclone is then with the interaction of these fronts together, and then the global circulation combined with them to create these spiral effects that move across the entire United States. Here's a great mid-latitude cyclone, again, sort of diagram, active little video for you to check in on. I'm not going to do it right now. I'll let you guys play with that. But what you want to do is be familiar with these weather symbols. And for the lab, you're going to be asked to draw these symbols, like what's going on here with Atlanta. By the end of the lab, you will be able to just look at these symbols and tell me what's the wind speed, the wind direction, the climatic conditions as far as, is it snowing, raining, is it sunny, cloudy, right? Just by looking at these little symbols and drawing them yourselves. And here's kind of a little breakdown there. And so cold front, remember these blue triangles. Warm front is these little orange half circles. I think of it as like, if it's really a cold front, you get these cold, chattery teeth. And then a warm front, it's like nice, warm smiles, right? These two different ways to remember the symbols. And then the last piece is an occluded front, which is when they begin to merge together, like you see here in the middle of this map, which would be over sort of Texas, Oklahoma, Louisiana. You get this, that's an occluded front where eventually they all cycle together, and you'll see these in these interactive little cartoons that I included with the slideshow and that are there. But as you go through, and these are different perspectives here. This is, say, from the side is the cross-section view, and then this other view to the right is sort of a top-down view of those. And you'll be drawing these for your lab this week. And you'll either be doing them on the computer in like a paint option, or you can just scribble them on a piece of paper, take a picture, and upload it that way. But you'll be submitting those, your work. And then eventually from occluded, there's the occluded, so it's sort of like a zipper. It's zipping together here. The warm and the cold kind of zipping together until eventually they just combine, and then they just sort of dissipate like a magic trick. And it's actually the cooler air forms sort of one like layers of a cake, and then the other, the warmer on top there. And that's dissolved. And let's see, that was, yeah, my last slide is picking up with severe weather, and we'll take it from there. Some of this stuff I'm thinking about, I might do another video and YouTube it up for you to just look at. A reminder, I did have some comments as far as just concerns with, you know, I can only cover so much of this material in a 1-hour lecture, but it doesn't mean you're not responsible for it, because it is assigned in the readings. And there's lots of supplemental things with the Mastering Geography to get your information that way. So this is not a traditional class, obviously, because we're online, but also in the sense of the way it's structured. You're not meeting 3 times a week or 2 times a week. So don't count on, if I didn't talk about it in lecture, you're not responsible for it. You are responsible for the material that's in the syllabus. That's what we're going off of. So just a reminder there, and I do my best to kind of give you some highlights is what I'm doing, working with this hour lecture time. So I will stop there and hang out for anybody and everybody that wants to ask questions, or just hang out and listen to other people asking questions and what the answers might be. But you are free to go at this point, and I look forward to seeing you all next week.